Good evening. I want to tell you an amazing story that happened to me whilst I was doing research on malaria and mosquitoes. When we figured out that Lucy, in the cradle of mankind, may have suffered from a bad health condition. She may have had smelly feet. And here's what we discovered. This here is the most dangerous animal in the world. It's the African malaria mosquito, Anopheles gambiae, the bite of which kills an African child every 30 seconds. And when Lucy stopped roaming the African savannah and settled down, this mosquito co-evolved with us, and she developed a strong appetite for human blood. Now, humans smell, we stink, much more so than other primates. We exude sweat that bacteria on our skin break down to more than 300 different volatile chemicals. We exhale another 100 different compounds. And malaria mosquitoes, they orient themselves at night by flying upwind in a plume of odors that we produce. Now, the female mosquito, which consumes our blood to produce eggs, has the ability to smell us with her antennae, on which she has receptor cells with which she can detect human odors, like carbon dioxide or fatty acids. And her preference for human blood indicates that she's probably using very human-specific smells to detect us. And it follows that if we know the nature of these chemicals, that we can use them to trap mosquitoes over distance to traps, and thereby interrupt transmission of the malaria parasite from mosquitoes to humans. And the question, of course, became, which of these hundreds of chemicals are the ones that the mosquito is using? And so you can put a person in a bag and collect the smell, or breath odors, and analyze it using mass spectrometry, and painstakingly start to test each of these compounds to see to which ones mosquitoes respond. But that, of course, is like searching for a needle in a haystack, so we had to think of something more clever. And then I stumbled upon an old scientific article by a Brit called Haddo, who in Uganda studied where mosquitoes were biting on the bodies of naked children. And he recorded a strong preference for biting of the face. And this struck me. Was it the breath or the smell of the face that was attracting them there? And so we set up an experiment where we put a naked volunteer in a large cage into which one by one we released mosquitoes of 4 different species and recorded carefully where they were biting on the body. We really did. We were amazed by the outcome that 3 out of 4 species had a strong preference for biting certain body parts. Our Dutch malaria mosquito, the Anopheles atroparvus, preferred to bite the face. In fact, 20 out of 100 bites occurred on the nose. The African mosquito, Anopheles gambiae, preferred to bite the ankles and feet, hence the word mosquitoes, you see? So rather than focusing on body odors, we could now focus on the smell of feet. And as you all know, the smell of feet of humans is very distinctive. And a lot is known about it because the pharmaceutical industry is interested in developing products to quench this offensive smell. And so when reading every article we could find about foot odor, we came across some remarkable statements. First, that cheese smells after feet rather than the reverse. Think of it. And then, of course, we have the Dutch word tenekaas, which refers to the white yellow stuff you have in between your toes. And third, that bacteria involved in cheese production may have originated from human skin. And so it dawned on us that the typical foot smell of certain cheeses could perhaps be used to attract African malaria mosquitoes. And secretly we conducted experiments and came up with a tiny little piece of Romedoux, Limburger cheese, that did the job. But how was it possible that we attracted an African malaria mosquito with a Dutch dairy product? And the secret lies in the bacteria used for inoculating the cheese curd, which belongs to the species Brevibacterium linens. And this bacterium provides Limburger with its specific foot smell. And interestingly enough, its cousin, Brevibacterium epidermidis, resides on the human foot. We have it, 2 same bacteria. So we tried to publish these fantastic results in the big journal Nature. And they came back to us saying, it's interesting cocktail party talk. They didn't believe it. But then Parasitology Today published it, put it on the front cover, but they published the issue on the 1st of April. So everybody thought it was a joke. But the national and international press, they loved this story. Here was a combination of food, of cheese, of a disease that kills more than 1 million people every year, and of course our smelly feet. Wonderful. But beyond being an hilarious story remained the fact that malaria is affecting 500 million people every year. So how were our results used? First, we analyzed the aroma of Limburger cheese, and we compared it to human foot odor and human sweat, and found a remarkable resemblance in the chemical composition. And we then created a synthetic blend of 12 compounds, which we could also use to attract the mosquitoes. And this was published back in 1997. And very little happened afterwards, until 2005, when Microsoft giant Bill Gates pumped $8.5 million into this field of research. Some compounds were added to the cheese odors, and the research moved from the laboratory to the field in Africa. And over the last few years, colleagues in Tanzania and the Gambia have conducted numerous experiments. And this year, 2010, they've come up with 10 compounds, which is 3 to 5 times more attractive to mosquitoes than humans. And needless to say, I'm very proud to tell you that 8 out of the 10 compounds in this blend originate from the aroma of Limburger cheese. And so, as you can see here, malaria is not just a tropical disease. We've had it in many parts of the world, but got rid of it decades ago. And it is hoped that the use of traps baited with Limburger cheese volatiles will one day help us to control malaria better. And in fact, that the smell of the feet of Lucy will one day serve us well. Now, for me personally, the great recognition came in 2006 when colleague Ruud de Jong and myself were awarded the Ig Nobel Prize in Biology, which honors, as you may have heard of, research that first makes you laugh and then makes you think. And finally, if you're interested in reading more fascinating stories about mosquitoes, read the book Mosquito, The Fascinating World of Public Enemy #1. Thank you.